Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on properties of Laplace transform. Laplace transform represents continuous time signals in terms of complex exponential, that is e power minus st. Laplace transform can be used to analyze signals or functions which are not absolutely integrable. Continuous time signals can also be analyzed effectively using Laplace transform. Laplace transform of unit impulse response is called as system function or transfer function. X of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. This is the time domain to frequency domain representation. While we taking from whole period, the whole cycle can be represented by d, that can be converted to frequency domain in terms of 1 kilohertz. The whole cycle can be splitted by 2, it can be represented by d by 2 for similar frequency domain representation in terms of 2 kilohertz with respect to amplitude and frequency. It can be classified into two types, that is bilateral Laplace transform or double-sided Laplace transform, unilateral Laplace transform or one-sided Laplace transform. Unilateral means we can taking the limits from 0 to infinite x of t into e power minus st into dt. Bilateral means we can taking the limits from x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. This is the time domain to frequency domain representation. While we from the linear differential equation we are applying the Laplace transform, we can get the Laplace transformed equation. For this algebraic function we can getting the Laplace transform function. For that Laplace transform function we can apply the inverse Laplace transform, we can get the time domain solution. That is nothing but your time domain to frequency domain representation. Properties of Laplace transform: x1 of t par with x1 of f, x2 of t Laplace transform par with x1 of f, a1 into x1 of t plus a2 into x2 of t Laplace transform par with a1 into x1 of s plus a2 into x2 of s. This is the linearity property. Next one, time domain shifting property. X of t Laplace transform par with x of s, then x of t minus t naught Laplace transform par with e power minus s into t naught into x of s. Next one, Laplace domain shifting property. X of t Laplace transform par with x of s, then e power s naught of t into x of t Laplace transform par with capital X of s minus s naught. When time domain Laplace domain scaling property, x of t Laplace transform par with x of s, then x of a t Laplace transform par with 1 divided by modulus of a into x of s divided by a. Next, conjugation property, x of t Laplace transform par with x of s, then x conjugate of t Laplace transform par with x conjugate into s conjugate. Time domain convolution property, x1 of t Laplace transform par with x1 of f, x2 of t Laplace transform par with x2 of s, then x1 of t into x2 of t Laplace transform par with x1 of s into x2 of s. Time domain differentiation property, x of t Laplace transform par with x of s, then d by dt into x of t Laplace transform par with s into x of s. Time domain integration property, x of t Laplace transform par with x of s, then integral over minus infinite to t x of tau into d tau Laplace transform par with 1 by s into x of s. This is the linearity property. We can get the proof. x1 of t Laplace transform par with x1 of s, x2 of t Laplace transform par with x2 of s, then Laplace transform of a1 into x1 of t plus a2 into x2 of t, which is equal to a1 into x1 of s plus a2 into x2 of s. Now we can apply the formula. X of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. Now we can apply the time domain function in terms of x of t. We can get a1 into x1 of s plus a2 into x2 of s. Next one, time shifting property. X of t Laplace transform par with x of s, then Laplace transform of x of t minus t naught is equal to e power minus s into t naught into x of s. Instead of we can apply in terms of time domain function x of t minus t naught is equal to m t is equal to m plus t naught, dt is equal to dm. Therefore, we substitute in your above equation, we can get integral over minus infinite to plus infinite x of m into e power minus sm into dm into e power minus s into t naught. Therefore, e power minus s into t naught into x of s. Translation in frequency domain, x of t Laplace transform pair with x of s, then Laplace transform of e power s naught of t into x of t pair, which is equal to x of s minus s naught. Integral over minus infinite to plus infinite x of t into e power minus st into dt. Instead of x of t, e power s naught of t into x of t. Now we can combine e power st both terms, we can get it as your capital X of s minus s naught. Next one, time scaling property, x of t Laplace transform pair with x of s, then x of at is equal to 1 by modulus of a into capital X of s by a. Substitute in your Laplace transform formula, we can get at is equal to m, t is equal to m by a, dt is equal to dm by a. Substitute in your above equation, we can get 1 by a into capital X of s by a for a greater than 0. For a less than 0, similarly we can get 1 divided by minus of a into x of s by a. By combining equation 1 and 2, we can get 1 divided by modulus of a into x of s by a. Differentiation in s domain, x of t Laplace transform pair with x of s, then minus t into x of t Laplace transform pair with the d by ds into x of s. We can get it a Laplace transform formula. While we applying the differentiation to x of s, we can get d by ds into x of s is equal to minus t into x of t. Now we can combining these two terms, we can get the differentiation property. Now we can see the assessment. Define Laplace transform. Laplace transform can be defined as x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. List the properties of Laplace transform: linearity property, time scaling property, frequency scaling property, time shifting property, convolution property, and then conjugation property, etc. Laplace transform of unit step function is given by x of s is equal to 1 by s. Define ROC of Laplace transform. The range of value of sigma for which the Laplace transform converges is called as ROC of Laplace transform. State linearity property of Laplace transform. x1 of t pair with x1 of s, x2 of t pair with x2 of s, then a1 into x1 of t plus a2 into x2 of t, Laplace transform pair with a1 into x1 of s plus a2 into x2 of s. Bilateral Laplace transform is also called as double-sided Laplace transform. Differentiation in its domain is defined as, therefore, which is d by dt into x of s, which is equal to minus t into x of t. State time scaling property of Laplace transform, which is equal to x of t pair with x of s, then 1 by a into, therefore x of at is equal to 1 by s into x of s by a. Thank you.